Hello, let's look at this examples. It's a normal distribution. It's a problem involving normal distribution. So read the problem, pause the video and try the question before look at my solution. In a certain school, 200 people took a mathematic test, alright, 200. So the score are normally distributed. So means that it's a normal distribution with mean, right? So we know that the mean will be 50 marks, right? The mean is 50 marks and the standard deviation is 10 marks here. Standard deviation square, this is a variance, right? As you know that normal distribution have to written in the form of mean and variance, right? This is the format. So standard deviation square will be your variance. So okay, then I already defined the distribution is mean and standard deviation 10, variance 100, right? So in a test, there are 200 pupils. So in a test, pupils who obtain 70 marks and above are categorized as excellent. Means A plus maybe. They said that 70 marks and above is considered categorized as or we consider it as excellent. Find the number of pupils in that category. Definitely, if you want to find the number of pupils in that category, means that it's a percentage of students from the 200 student, right? Peratusan, berapa peratus daripada 200 pelajar ini yang ambil mathematics test mencapai kecemerlangan, right? Means that 70 marks and above. So we need to calculate the probability first, right? There are 200 pupils take the test. How many percentage from the 200? Not all, right? Definitely not all were getting excellent, no. So they will say that 70 marks and above. 70 marks and above means that it's considered as excellent. 70 marks and above, right? Considered as excellent. So we have to calculate the probability. The probability here is the percentage actually. So you can change this become a standard score Z. Then you have to write in 70 minus the mean to standardize the score. We have to standardize the score, right? In order to using the statistical table. So we're taking the 70 minus with the mean 50 divided by the standard deviation 10. Standard deviation is 10. So which is PZ greater than 70 minus 50, 20. So you're getting PZ greater than 2, right? So with the Z greater than 2 is already it's a positive value and it's greater than, we can using the statistical table here. So we find the table 3, from table 3 where's the score Z? 2, right? 2, 0.0228, right? 0.0228. This is actually the probability of student that greater than 70, not much, right? If you know the meaning of probability, you know that this value here is quite a few of them, right? Only a few of them. It's just if you want to convert this become percentage, it's actually 0, I think is around 2.28% only, right? 2.28% only of them is score more than 70 marks, excellent. So very easy. So the number of students, right? The number of pupils in that category, the number of pupils categorized as excellent, right? Categorized as excellent is equals to, you take the number of sample out of the 200. Out of the 200, this is the percentage. This is the probability, 0.0228. So once we calculate, we know around how many students out of the 200 is. So if you calculated, you just give around 5 of them, all right? Around 5 of them. So it's a nearest integer, right? Round off to the nearest integer. We are getting 4.56. So we just round off it become, okay, we estimate that it's around 5 lah, okay. It's just a number. We're telling the someone that, okay, out of the 200, it's just 5 of them getting A. Oh, so few of them. So that's the meaning here. Alright, okay, look at the next question. Given that 60% of pupils pass the test, 60% pass the test, calculate the minimum score to pass. Alright, usually I will tell students this is a normal distribution, you know. This is a normal distribution. So a normal distribution having a mean, right? A mean here. So the mean here will be 50, right? 50. So 50, most of means that the mean value for the marks will be 50%, right? 50 marks. So now they say that 60%, right? 60% of the pupils pass the test. Pass the test. So pass the test means that you know that they will exceed some value. Alright? Pass means greater than. Pass means that they were more or same with a value here. A value, a marks. A marks. Do you know the marks? No, we don't know now. Okay, we don't know what is the passing mark. We don't know the passing mark. So we set it to be less than. Definitely it's not less than. Tak mungkin kurang. Kurang daripada markah itu mestilah gagal, right? Mestilah gagal. Mana boleh kurang, alright? If you want to pass, you must be greater than a certain value of mark. Kalau anda nak lulus satu ujian, mesti lebih atau sama daripada satu nombor tertentu, right? Nombor itu maksudnya markah tertentu supaya dia lulus, right? So greater than a certain value of marks, then it considered as pass, right? So we don't know where is the mark, but we know that it's 60% of the student, right? 60% of the student, 60% means 0.6, right? 60 over 100, right? So 60% of the student, definitely the 60%, this is how many percent? This is how many percent? 50%, right? This is 50%. 50% of the student is greater than 50, right? The marks is 50, right? The marks is 50. So this is 50% greater than the 50 marks, right? If the value here is 50, if the value here is 50, then this will be 0.5, right? 0.5. But the passing mark means that the passing mark is even lower than 50. The passing mark is lower than 50 because why? You see 0.6 mark, right? If you understand mathematics, you're able to read the meaning here, right? 0.6 here means this is 0.5, right? 0.5 means that it slightly go to the left again. Slightly go to the left again, okay? Slightly go to the left again to make it here become 60%, right? Another 0.1. So total everything here will be 60%, right? 0.6, 0.5 and a little bit of this. So means that the passing mark is less than 50 marks, right? Less than 50 marks. Okay, doesn't matter. This is for your knowledge, all right? This is for your knowledge. So what you should do is you should standardize the distribution. Standardize the distribution. Standardize this one means that you change this become Z. Z less than M minus with the mean divided by the standard deviation 10 is 0.6. After you standardize this, it become the mean becomes 0, right? Standardized. Then definitely your value here will be your K. I let this to be K. This to be K. I let this to be K. K equals to M minus 50 over with 10. So means that this is the value of K, right? Which is 0.6. 0.6. Takkan itu maka lulus kat sini, right? Takkan dekat sini. Impossible. This is less than 0.5, right? It definitely will be more than the mean, okay? It's K. K is here. K is as a, after standardized, right? After standardized, K is at the negative region because it's a value less than 0, right? So, okay. So we know that the value of K is here, right? The value of K is here, right? So we have to convert this distribution. Convert, okay. I show it to you. So the value of K is here, right? The value of K is here. So this is the same as I taking everything, you see that everything minus away a small part of here, right? So if I taking everything 1, right? Everything is 1. If you see that everything is 1, the missing part is here, right? Because they minus away this part here. So this part is K. So, but you have to remember that this everything means that 1. minus away. This one you cannot read from table because our statistical table for matriculation is reflected to the right. It's on the right, the upper tail. So means that it should be here, right? It should be here. This is for your knowledge, okay? It's not the step, it's just to guide you, all right? So I put a negative k here. Sir, why you put negative k? Why never maintain as k? Because you from a negative to become a positive, right? Some of you still cannot understand, maybe, all right? Negative 2. Let's say, if k is at the negative side, right? At the negative side is something less than 0. I just give an example, for example, negative 2. So is the region, the area for this is the same as 2, right? Negative 2 less than negative 2 is the same as greater than 2. Can you see that the value from negative become positive? So you know that k is a negative value, is on the left hand side, right? So in order to become positive, you have to multiply with negative, right? You have to multiply with negative, means that negative of the negative 2 become this. If this is k, this will be negative of the k. That's why you have negative k here. Take some time to go and understand this, okay? So now you know that the value of this will be, I can rewrite this whole thing to be p z greater or equal k is 0.6, right? Pz greater or equal k is this one, is this distribution. As I just now explained, you can change become this distribution, which is equals to 1 minus pz greater or equal negative k. So, okay, now I'm going to show you how to find the value of k. Alright, okay. So I've explained just now, you take some time to go and understand that. Once you get the idea, you were able to do many type of the question involving normal distribution. So, and this word I already converted, become this one. So if I just tell you that this one is not convincing you at all. So I just now have explaining to you. So this is why I'm getting this, alright? 0.6, right? So pz greater or equal negative k, right? Negative k is the same as, okay, this one go to the side. So 1 minus with 0.6, you're getting 0.4, right? 1 minus with 0.6, you're getting 0.4. Okay, now, very simple. You can using statistical table already. Why? First, because it's already greater. It's already greater. Second condition here is already less than 0.5. It's already less than 0.5. So, okay, you look at here, is 0.4. There are no value of 0.4 here from table 3, right? The perfect value don't have, or is 0.4. Okay, mana? 0.4. Where got? No, right? If you round off, you're getting 0.4 lah, okay? But it's not accurate, so that's why they introduced another table, table 4. Okay, table 4. So if here is 0.4, so from here you see where is 0.4? Yes, 0.4, right? 0.4 is 0.2533, the z-score. So it means that negative k is 0.4 will be 0.2533, right? So k will be negative 0.2533. So from here you can find the marks, right? The passing marks here. The most important is the passing marks here. So we equate the m minus with 50, over 10. The k is over 10 equals to negative 0.2533. So m minus 50 will be negative 0.2533 multiplied with 10, and m will be negative 50, become positive 50, plus with negative 0.2533 multiplied with 10. So the passing marks will be, the most important, we want to know the passing mark, which will be, alright, so the passing mark, because this is a marks, right? Marks is a continuous random variable, so you can take the decimal value, so it's actually 47.5 lah, alright? 47.5. So if we round off to the nearest one integer, either you nearest it to the one decimal, or usually we will round off to the it become 47 marks, because from calculator is 467, right? 467. So usually we can round off to the nearest integer. The marks, we can say that the nearest integer, the marks will be 40. Round off, it will become 47, right? 47 marks. So means that 47 marks is the passing marks. Okay, means that 60% of the student, the marks is greater than 47. Okay, this is the estimate value, alright? It's the estimate value. So it's actually the value is 47.467. I just round off, okay, 47 marks, alright? So means that the passing mark is actually 47.467. So I round off to the nearest integer from the question. So I'm getting 47 marks. So means that as long as the student getting 47.5, because I already round off, so as long as you're getting 47 marks or above, we consider as 60% of the student that passing the test, alright? Passing the test. It's just an estimation, alright? Probability is about estimation, right? Okay, that's all for this question.